right, here we go. So now the second half of our chapter is going to be on something called rational functions. And so the phone company problem was an example of rational functions. So we're going to start with foundational skills. In order to simplify a rational expression, you have to be able to factor polynomials. So good thing we've spent a lot of time doing this. I'm going to pause and give you about a 2 or 3 minute head start. And I want you to go through and factor as many of these as you can before I get to it. What is step 1 in factoring? GCF. So don't forget about the GCF. Because some of them, that's the only thing you can do is factor out a GCF. All right, Lily, on letter A, what's the GCF? What could you factor out first? Don't they both also have an x? Yeah, so we're going to pull out a 3x, and I'm left with x plus 5. That's as far as that goes. All right, Max, what'd you get for x squared minus 4? How did that one factor?
X plus 2, x minus 2.
Nice job. X plus 2, x minus 2. All right, Hannah, how does x squared plus 2x minus 15, how does that one factor?
X plus 5 and x minus 3.
Yes, you got it. All right, then we're going to do one that's a little bit harder now. All right, Cal, what'd you get here?
3x plus 2, x minus 3.
Okay, so I'm going to check your work. 3x times x is 3x squared. Negative 9x plus 2x is negative 7x. 2 times negative 3 is negative 6. We got it. All right, Liam, in letter E, what's the GCF? What number can I pull out of both 2x squared and 18? 2. So I can pull out the 2, and I get 2 times the quantity, x squared minus 9. Then Mackenzie, how does that continue to factor?
I got like 2 and then x plus 3, x minus 3.
Good job. You got it. All right, then Humera, what's the GCF in letter F? 4x, and that's going to leave me with what? X squared minus 7x plus 12. And then Gabe, what was your final factors?
4x times x minus 4 and x minus 3.
All right, we got it. So factoring is going to be foundational to this half of chapter 6. When simplifying rational expressions, we can cancel common factors but not terms. So first of all, I'd like you to highlight that statement. Okay? When simplifying rational expressions, we can cancel common factors but not terms. So let me pause a moment here and go over this, what this is, okay? Let's go maybe up to the tippy top. Terms are separated by addition or subtraction. So for example, 3x plus 5, 3x is a term, 5 is a term. So you would have learned this in pre-algebra and algebra 1. Terms are separated by addition or subtraction. So if I have 3x plus 5, 3x is a term, 5 is a term. Factors are separated by multiplication. So if I have 3x, 3 is a factor, x is a factor. Okay, this is foundational. If you don't understand factors and terms, this will be a disaster unit. So I've got to make sure that you understand this. Again, factors are separated by, and that little x means multiplication, okay, by multiplication. So if I have 3x, 3 is a factor and x is a factor. So let's go back to the highlighted part again to make sure you understand it. When simplifying, we can cancel common factors but not terms. So what I mean, let's do an example. If I have 2 plus 5 over 2 plus 7, the 2 and the 5 in the numerator are terms. The 2 and the 7 in the denominator are terms. I cannot cancel the 2's. So that means I can't cancel x's. If the 2's were actually x's, I can't cancel them. Because do you understand that a variable holds the place of a number? Okay, a variable, an x, just holds the place for a number. So if I can't do it with a number, I can't do it with that letter. So this is 7 over 9, not 5 over 7. Like if you wanted to cancel those 2's. I cannot cancel terms. All right, a quotient of two algebraic expressions, a over b, is called a rational expression. So here are some examples of a rational expression. 5x over 3, 12 over x minus 4, 3x plus 1 over 2x minus 5, x squared minus 10 over x cubed minus x squared plus 3. Note, if I look at this one right here, 12 over x minus 4, I can't have x be 4 because that would make me divide by 0. So we're going to talk about the domain. Okay, we're going to talk about domain comes back into play. So in my first example, it says determine the value or values for which an expression is defined. Here's what you do. Set the denominator equal to 0. That will be the restriction. So, in the first one, I'm going to set 2x minus 5 equal to 0. Oh, this is super cool. You can see why back in Algebra 1 you were solving these equations. Okay, so now you can see your prerequisite skills, and I'm getting x equals 5 halves. So my domain is going to be all real numbers except when x is 5 halves. Does that make sense? Because if I put 5 halves in, I'd be dividing by 0. Oh, now you can see why you did quadratics. All right, so in letter B, set the denominator equal to 0. Let's try to factor it. All right, Drew, how does this one factor?
X plus 7, x minus 1.
Good job. So you get x is -7 or x is 1. So here's what we're going to write. These are the restrictions. These are the values. And so when we write it like this is saying all real numbers except these two numbers. All right, and I do think like you're going to see, oh, this is why she's doing it. This is like a fairly simple lesson and easy enough for us to do right before break and not have any homework on it. So if you have a negative in a fraction, there are 3 places you can put the negative. You can put the negative in the numerator, you can have the negative in the denominator, and you can have the negative in front of the fraction. What I'm going to tell you we're going to agree upon is putting the negative up in the numerator, okay? We're going to agree so then all our answers will look the same. All right, generally speaking, a fraction is not written with a negative denominator. So 2 over -5, we typically write it as -2 over 5. All right, so let's take a look at this next example. If you want to simplify, so let's write ourselves a note. Factor the numerator and denominator then cancel common factors. Determine domain from the original fraction. And a rational expression is just a way that we say we're going to do a fancy fraction. Okay? A rational expression is a fancy fraction. All right, so here we go. Up in the numerator, let's go ahead and simplify, and we're going to factor, okay? In the numerator. So you can like see the beautiful connections to everything we've been doing, like it all connects together. So in the numerator, DP, what's the GCF? What could I pull out of all 3 terms? 5x. Nice work. So that's x squared plus 2x minus 5. Now, okay, I'm going to make a connection. Here we go. So look, do you see where we wrote up at the tippy top? Do you see 5x is a factor? 5x is a factor. 10x squared is a factor. I can cancel with factors, but I can't cancel with this in here because that's inside there is a term. Those are individual terms. You have to run around. All right, so watch what I can do. I'm going to use a different color so you can see this. 5 goes into 5 one time. 5 goes into 10 twice. X cancels, and I'm going to cancel one of those x's. So I'm going to get x squared plus 2x minus 5 over 2x. I cannot cancel the 2x's because up in the top, that 2x is a term. Does that make sense? Yeah. The only time you can cancel is if it goes into everything in the numerator. Now, for your domain, you do it from the original fraction. You set the denominator equal to 0. Well, that's not bad. So x just can't be 0. All right, so let's try this. I do the domain typically first. So set the denominator equal to 0. So we would just say x can't be negative 3.
What does that even look like on a graph? Like how is it, does it just like skip over -3? Facts.
Okay, that's an excellent question, which we're going to talk about after break. One of two things happens, okay? And that was it negative 3?
Yeah.
Okay. One of two things can happen in a rational expression. It can either be what we call a vertical asymptote. There can be a vertical asymptote, or there's a hole in the graph and it's doing something like this. Excellent question. We aren't going to do the graphs in Algebra 2. If you go to pre-calc next year, you'll do those. But great question. All right, up in the numerator, this is going to factor into x plus 1 times x minus 1. And I have to tell you a little math secret, okay? I'll tell you a little math secret here. When you're doing rational functions, if you're not so swift with your factoring, good news, there's clues. So do you notice there's an x plus 3 in the bottom? There's a 99% chance there's an x plus 3 up in the top, okay? So that's not so much of a secret. So now the x plus 3's cancel because they're factors. Do you see it's a quantity x plus 3 times the quantity x minus 1. So now that's x minus 1 is my final answer. All right, I'm going to pause a moment and I want you to try the next two. Okay, I'm going to give you a little head start on me. Set your denominators equal to 0. Well, actually, I'd maybe factor them first and then set the factors, because that would be easier. So factor your numerator, factor your denominator. Once it's factored, you can cancel common factors, but the domain, the allowable values for x are from the original. So if you know how to factor, this is going to be a breeze for you, just an absolute breeze. There's just one tricky thing that we're going to do after this second one. And once you get the hang of that, then it's not too bad.
You write it like these values.
Yeah, well, wait a minute. X minus 3 and x plus 3 don't cancel. They're not identical.
Oh, they have to be identical.
They have to be identical. Well, that's like saying I have 5 over negative 5 isn't 1, but even that's not negative 1 either. We'll talk about that. Because think about it. Pick a number. Pick any number. Like 10. 10 minus 3 is 7. 10 plus 3 is 13. 7 over 13 doesn't, you know what I mean? Like that's, I think you're thinking if they were factors. All right, Matthew, on this first one, x squared plus x minus 12 over x squared plus 7x plus 12. Can you read off your factors for me?
I'm not done yet.
Okay. Well, can we do it together then? If I have,
Absolutely.
okay, if I have x squared plus x minus 12, so you know you're going to put an x and an x. What two numbers multiply to negative 12 but add to 1?
4 and 3.
Good job. Plus 4 and a minus 3. Then in the bottom, if I have x squared plus 7x plus 12, what two numbers multiply to 12 but add to 7?
4 and 3.
4 and 3. All right, so right here for my domain, I would set the denominator equal to 0. So that's going to be the domain. Then the x plus 4's cancel, and I get x minus 3 over x plus 3. And then for some reason, this is so tempting to students to try to cancel the x's and or cancel the 3's. Let me show you why we can't do that. If, let's say, if I let x be 10, 10 minus 3 over 10 plus 3, do you see that's not negative 1? Like, that is not true. So and that's why, and I don't know what it is. It's like if we put letters in, we think we can do things that you really can't do. Try it with a number when you're not 100% sure, and that will usually help yourself. Ooh, I hope I fixed, oh, I didn't fix it. Did I fix it on yours? Do you have a plus down here?
No.
It's supposed to be a plus, because otherwise you're probably sitting there going, this isn't doing anything. Well, I guess it could work that way, couldn't it? So this would be x minus 1, x squared plus x plus 1. And that's x minus 1 times x minus 1, right? So for my domain, I don't need to set x minus 1 equal to 0 twice, just once. And then one of your x plus 1s cancels. Does that make sense? Okay. All right, then, to just round up the notes here, there's one last sort of tricky part. If you have a minus b over b minus a, let me go through a process here with you. In the bottom, okay, go ahead and just write every step with me. If I switch the order, that's called the commutative property. You learned that back in Algebra 1. I could switch the order. And then watch this. What if I choose to factor out the negative 1? Oh, guess what? Now I can cancel the a minus b's, and that's going to leave me with 1 over negative 1, which is negative 1. So here's the big idea. If you see a minus b over b minus a, you can always reduce this to negative 1. So let's do a quick example. If I had 5 minus x over x minus 5, that's negative 1. Here's a non-example. If I have 5 minus x over x plus 5, that reduces not. It just doesn't reduce, okay? It has to be that they're both subtraction and in the reverse order. Then that'll cancel to negative 1. All right, so here's what I want you to do. I want you to try the next two examples on your, there's two, but one of them has two parts. So try to factor everywhere. And what's going to happen in some of them, you're going to see an a minus b over b minus a. Do as much of it as you can. Now, do you notice in this first one, 4x squared minus 23x minus 6, that looks a little scary to factor, but your clue is in the denominator. Do you see a 6 minus x? I bet you we have an x minus 6 up in the top. Try it. Try x minus 6 with the other part you might need instead of working so hard. Does that make sense, what I'm saying? So the numerator looks tricky, but the denominator is giving me a clue. all three of these, okay? This one plus there's an AB part. Now, when you're doing part A in that last example, I know that looks a little confusing. You cannot cancel terms, but can't we factor the numerator? You can start with GCF. Okay, you cannot cancel terms. All right, so let's go ahead and take a look at these. So this first one, I'm going to probably guess that I have an x minus 6. So that's got to be 4x squared plus 1. Do you see that? Let's check. Oh, not 4x squared. Kidding. Just kidding. 4x plus 1, because that's x times 4x is 4x squared. 1x minus 24x is minus 23x, and negative 6 times 1. Okay, so that works. Now look, x minus 6 and 6 minus x are going to cancel to negative 1. That's what we just learned. A minus b over b minus a is negative 1. So I can either leave it as negative 1 times 4x plus 1, or you could distribute. Let's go ahead and talk about domain. You set 6 minus x equals 0, so x equals 6. That's the one value I cannot plug in. Even though the denominator cancels, the original problem, it has to work in the original problem, not just the reduced answer. All right, questions on that one? All right, in this next one, I have a GCF of z squared, and I get w minus 1. In the bottom, I have a z cubed, and that's 1 minus w. All right, can somebody talk me through how to simplify this one?
The z's cancel.
Okay, 2 of them do, and that leaves me with a z in the bottom. And then what's the next thing I could do?
-1.
Yeah, w minus 1, 1 minus w is negative 1. So I end up with negative 1 over z. Now I have 2 letters here. So when I do domain, I've got to be careful. And I'm going to use the factored. I would set z cubed is 0. So z can't be 0. And 1 minus w is 0. So my domain is z is not 0 and w is not 1. So when you do these, you're always going to state your domain. All right, on this one, I'm going to get what? X plus 4, x minus 2. I can pull out a 3. I get x plus 3, x plus 1, x minus 2. So an x plus 1 cancels, an x minus 2 cancels, and I have 3 times x plus 4 over x plus 3. My domain is x can't be negative 3, negative 1, or 2. Can you see it from the factored denominator there? All right, oops, sorry, I didn't realize there were a couple more on here. All right, so it says simplify. So go ahead and factor your numerators, factor your denominators, state your domains. And so what I do, like if you're looking at letter B, that numerator looks a little tricky. So, but the denominator looks easy. X squared plus 2x minus 15. Sometimes I start with my denominator and work my way backwards to the numerator. Then I'm like, okay, it's either going to have a x plus 5, x plus 3 component, or, you know, whatever the signs are. All right, just because I'm low on time, I'm going to go ahead and work them out. So I get x plus 2 times x minus 2. Down in the bottom, I've got to do some factor by grouping. Can I cancel the x plus 2 right now? No, because the bottom is not completely factored. Those are terms. So now I factor out the x minus 2, 2x squared plus 5. Now is where I can cancel. And I'll have x plus 2 over x minus 2. You cannot cancel the x's or the 2's. That's not -1. My domain is only x can't be 2 because this gives me imaginary. And I'm looking for the domain over the real numbers. All right, then this is what I was talking about when I was talking about working myself backwards. So the x minus 3 cancels. I get 3x plus 2 over x plus 5. My domain, x can't be -5 or +3. Woo, okay. If you want to do some extra practice, there's 3 more.
Hey Bears,
Kicking It is live.
come join us on YouTube.
Okay.